Hello, everybody. How is it going? How is everybody's evening going? Welcome to the stream. Welcome to the stream, everyone. I hope the music is not too loud. I hope you had a good day. I hope you're having a good day. I hope you had your dinner. I didn't. I didn't because I'm a late eater. But yeah. How's it going, everybody? How's it going, everybody? If you're watching me live, feel free to chat live. If you have any questions, to drop the questions. If you just want to say hi and hang out, I'm here. Yeah. Okay. So it is 10:10 p.m. in India time, and we have just started. And what are we doing today? Today we are gonna chill. I had a hectic stretch of office for the last 2 to 3 days, and last 2 days. And the question is, what are we doing today? Well, we are just gonna chill with some algorithms. We're not gonna try too hard. Well, I probably never try too hard, and that's why I cannot solve a lot of Leetcode problems, I guess. That's fine. We're gonna try and solve a bit of problems. We're gonna pick up from the place that we actually left day before yesterday, I think, with binary trees, and we're gonna go with that. And we're gonna try and see how many binary tree problems we can solve today before we log off and we run out of battery. So I'm doing a live stream after office, after a long day, and after a lot of work in the evening at home also. So kind of tired, but I still want to put in a little bit of effort every day towards upskilling, and that's one of the reasons why I am streaming today. Yesterday also I spent about a hour in the morning, but yeah. So every day I try to give in at least an hour. Anyways, that's what we are doing today, and I have put in the code where I have put in the GitHub link in the chat. Feel free to look it up at there. See exactly like what I'm working on. I would be putting a lot of information there. It is for my own information also, but the reason why I call it interview preparation is because most of the people would kind of run after those kind of tags, and it's easier for you to find that. But it's not going to be specific to an interview preparation. It's going to be overall software engineering preparation, including OS. I'm going to later on explore OS, later on explore networking more, things like that. But mainly probably the software layer. Okay, but mainly probably the software layer. But I mean by software layer, app layer, not low level. But yeah, since I am growing interest in low level also, I've also started doing that. So if you guys are already aware, sorry. Did my stream just die? No. Okay. So YouTube is being stupid. That's just YouTube. But anyways, hello everyone. How's it going? Feel free to say hi on the chat. I hope you had a good evening. And since it's already 10, so we'll wait for 2 more minutes and see if anybody joins. And then we're just gonna go live and start solving some problem, grinding some problem, things like that. Okay. Yeah. So one of the things is very annoying is I keep opening this thing here. So what I'm gonna do here is I'm just gonna open this thing in here so that I don't quite often open like Firefox. So holy shit, Firefox has a AI mode now. Man, every browser has gone crazy. It's really dumb. Every browser has gone crazy. I personally feel every browser has gone crazy, man. It's... What is the point? What's the point? What are you achieving? What are you achieving with having AI integrated into your browser? I am personally afraid to expose my certain things and my searches to AI, let alone like I'm even afraid to I try to not expose my data to any third third-party companies, let alone AI. Anyways, so I have opened it here. Just give me 1 second. I'm gonna quickly do. I'm not gonna do a sign in. I'm just gonna keep it like this for now. I'm gonna keep it running. Okay. And let's get started. So we're gonna get started with Premium Algo 100. So if you're actually following me and you're trying to solve this study plan, I'm sorry. This if I'm not under Premium plan and I have Premium plan. So I'm sorry if you do not have the Premium plan. I'm really sorry for that. But I mean, yeah, you can probably. I'm not gonna share it on stream, but you can probably find some knockoff websites where you can find the same problems, and yeah. Cool. Saying that, let's get started. Also, I didn't actually do today's problem, so maybe I'll do today's problem first. It's a hard problem, which means it's gonna take at least 30 minutes. Let's see if the problem is easy to solve. If it is, solve it. You're given an integer array target, you have an integer addition. I think I'm not gonna solve it because, like, what I came up with the mentality of solving binary trees, and exactly the one that this one. This is the one I came up with. This thought that okay, I'm gonna solve this because last time we couldn't. So I feel like we should be solving this first. Okay. Okay, cool. And I'll start solving it and I'll start explaining it. If you have any questions, feel free to just ask in the chat, and I will try my best to answer your questions. Okay, cool. So the question was basically very simple. You have a binary tree and you have to do a vertical order traversal. So you do traversals in this way. So the very first value would be 9. Then if you see 3 and 15 is on the same level, if you take like column wise, so it's in the same column. So that's why it comes second, but then 3 comes before 15 because if it's on the same level in the column, you first take the lower number row. You then take the lower number row. Things like that, and that is how you absolutely go up. And then you have 15, then you have 27. So 3 9, 3 15 27. Okay, so last day we messed up a little bit here and there because we were trying to solve it in a different way where as a matter of fact I solved it, and I'm pretty sure I solved it in this way because that's what I can only think of right now. Oh, and one more thing here. So 0 and 1 is on the same level. So 0 comes first, then comes 1. Okay, so that's one thing we have to be a little bit careful about. But anyways, we always will come with 0 in the first place because of the fact that you already have like if you're doing a DFS from the left hand side, you would first always come to 0 and then always come to 1. So we should be good with that, I suppose. Just give me a second. Though I'm wearing a hoodie and it feels it's cold, and it's a little bit cold. It's not that cold. But yeah, it's a little uncomfortable. So if I wear the hoodie and switch on the fan a little bit slow, so that is kind of like the sweet spot, you know? The sweet spot. Cool. Okay. So let's see the problem exactly where we left and what's the problem. The main problem here I feel is this. Okay? So let's do this very simply. So at the very start, you have a single so you always add a new array list and you send it. So you always add a spot in here and you say cursor is 0. Okay? So the very first time the offset will be 0. The offset will be 0. Right. And if offset is 0, you just get the origin. Wait. That's correct. So I'm calling this origin or midpoint. So I get the origin, which is origin is 0, not cursor. Anyways, whatever. So you get this point and you get the origin and add the value. That's all. Cool. So for the very first time you're trying to go through it, node.value is key, and list is this. So not val, and then you also have that later. Okay, which is an integer. Yeah, okay, cool. So the very first time you see this makes sense. Then you would go down left and you would add here, also makes sense. Then you would go down to the right. This is where you mess up things. Okay. Aha. Because you do this. Because you do this. How about now? Ah shit, I didn't plan to debug or something. Did I just run debug? I'm not sure. What did okay. It still is wrong. That is fine as of now. That is fine as of now. So 20 here should be plus 1. Why on earth you're telling me? Okay, we gotta do some things here. Offset. This is the origin. So if this is negative, so let's remove this first. Let's just think it through correctly. So if it is negative, you have an origin in here, right? So if it is negative minus 2, let's say, the entire point is that if you have negative minus 2, it means you need two elements like this. So it's actually minus 1 and then minus 2. You need two elements. Right. So now 0 minus origin has to be greater than or equal to minus 2. Correct? Why? Greater than or less than? Man, this negative thing is going crazy on my head. Okay. Because if this was minus 3, then minus 3 minus 0 is minus 3. So this is less than or equal to minus 2. So we don't have to add. But if this was greater than or equal to so greater than the offset, that is minus 2, this is when we had to worry about these kind of things. Okay, offset minus origin, if it is greater than offset, add first, new arrest. Then what you simply can do is you can say that origin minus offset, so it has to be 2, that is when you go to 0, right? Origin minus offset later get add this thing. And if you're adding something here, you have to say origin plus plus. So you have to shift that bit. You have to shift that when you're adding a new thing, because yeah. So let's say you had to put something in minus 2 and there was only 2 slots, and this is origin, right? This is origin, which is at 1 right now. So you would say offset minus origin. Just this. So minus 1. Is it greater than minus 2? Yes, it is. So we have to add something in the first. We add another thing, and then we move the offset in. Then we move the origin in. The origin is now 2. Now you simply say origin minus offset. So 2 minus of minus 2. It becomes 0. Pretty cool, huh? I feel like we did the same thing, but we did mess up before, or something was missing. Let's see if this is the correct one. Okay, so we still are not correct. A boom, a boom, a boom. Okay. Accumulator dot get shrink minus offset. Why does it become 2? It has to be plus, buddy. Sorry. Okay. And then you go here. The problem arises when you pass 15, which is on 0. So it doesn't go here. It should go here. Should go here. Okay, so you're wrong here too, but we can fix that. What's the offset? The offset here should be 1. We're not changing the offset anywhere, right? Yeah, the offset here should be 1. So whatever that origin was, which is supposed to be 1, sorry, origin was 0. Remove that, origin became 3. Cool. Now I know the exact problem. Because you are unwinding the stack and your state changed. That's the problem. I personally do not like the solution, I'll be very honest, because sorry, this has to be plus, man. Yeah. Okay, so here's a problem. Okay, so 6 first came in because why 6 first came in? So you go left, keep on going left, then you unwind and you keep on going right. So you just process it later. So you just process it later and that should fix. But okay, what is the problem here? So origin plus offset. If the always have to do that, right? Man, am I going crazy? I feel I'm going crazy. Ah, but why did I use a Q? Why did I use a Q? So one of the reasons I might have used a queue is because of this particular thing, where I need to first process 10 and 9, so I kind of have to do a BFS and not a DFS. And that's why I used a queue. That makes sense. So our entire solution was wrong to begin with. Kind of. I don't quite like this. But I mean, since we don't have closures here, we can still have closures, but then I have to somehow manipulate this, because within lambdas I always have to take some final variables, but this one is fine, it's a final variable. I'm just changing the state of it. The binding is still same. The binding is what that matters, not the state. Since these are primitives, I can always do this, but then this is already cached from like in the level up in the range of short. So one of the things I can always do is this. And to be fair, if I'm doing this, I can simply pass it around the method and pass it down the method, right? So for this particular use case, I'm going to do it this way. So my entire concept was right, but except the fact that we have to do BFS, because whatever rows are at the top, you have to first, work with them. So let's try to do that, I suppose. Deck, tree node, queue, new array. Queue dot offer while queue is not empty. I can simply do this trick where I can say the queue poll tree node is this. We kind of also need a biasing. Private record pair. So node and int offset, I can say. So this has to be a pair. So pair root 0. I wished we could have. I mean, there is no way of doing this thing, because like how do you then define the types? But then since you have type inference, maybe you could have done that. Destructuring, I don't know why is it not allowed. It would really have been really helpful with Java, but yeah, okay. What are we supposed to do? So now I'm supposed to say this thing. Okay, so pair.node is this, and then int offset is the same. Okay, if offset, so list of list of integers is the result, and then here I can simply say mid is 0. Right. So if the offset is 0, so in here what I do want to do is add new list. So I know as a matter of fact key it has to be this, because I've already eliminated this use case, which means at least one row is absolutely needed, right? So I don't have to do any checks in here. I can simply do get of mid and this thing. That's pretty much it. Else if offset is negative, then what do we do? So this is where our maths would come into the picture. So you have 3. So let's say this was the midpoint. So this is your 0. This is your 0, right? And what you want to check is if it is -1, then 0 minus mid. 0 minus mid would in case give you 1 in here. I'll give you -1 plus 1 in here, right? No, why? Am I going crazy again? It would give you -1 in here. So once it gives you -1 in here, I would want to say my offset was -1. So this has to be less than or equal to, because I want to have more stuff in here. If I have less, that's a problem, because if the offset was -3 and I had only one element in here, which is -1. So, okay. Minus mid is 0 minus mid. Well, it's minus mid, but let's be explicit here. If it is greater than offset, this basically means that accumulator add, but you gotta add in the first place, and you gotta move the mid cursor in here. Okay, accumulator dot get. So it was always -1. So how do you get -1? What is the exact position? You can say mid plus this thing. So it was -3 and this was in 4. 1, 2, 3. Well, technically it should have been 0, 1, and that is what it is. So mid, get of mid minus offset and this thing. Else, so now this is mid, right? So mid is, let's say, 2, and you want to put at an offset of 3, which means you need one extra space in here. So length, well, very simply speaking, you know what, let's do a very simple thing in here. Mid is positive, this is negative. If it is less than 0, it means it would go out of range for you. I think simple solution. This is exactly what we did, right? Offset on the other side and this thing. Yeah, so this is what we need to simply do. In here, if offset plus mid is greater than equal to accumulator size. Wait, sometime we are writing accumulator, sometime we are writing, oh, because I didn't actually delete that, and that's why it's gonna mess up. This is result, this is result, this is result, this is result. Okay. I want a little beat songs, right? Yeah, boy, we want that. We want that kind of song. We are that kind of people, right? So the next thing I want to do here is that Well, where were we? Yeah. Okay. So result dot get. Now the question is, how much do we get? So if the offset is 1, it means just plus 1. And I think that has to be this. Yeah. Feel like wait a second. Okay. Marfa is always an issue, huh? If the offset is less than 0 and ooh, uh, okay. If the offset is less than 0, so let's say the offset is -1 at the first, right? And your cursor was 0. So -1. So mid was 0 to start with, plus offset, which is -1. So -1 is less than 0. Yeah, okay. So you have to add something in there. Aha. Oh my god, finally. Took us 15 days to solve this problem. Thank god we did finally. Hey, cool. I would say pretty cool. Let's try to solve the next one. Maximum average subtree. Okay, longest consecutive sequence. So what are you saying? Given the root of a binary tree, return the length of the longest consecutive sequence path. Binary tree, okay. A consecutive sequence path is a path where the values increase by 1 along the path. The path can start at any node, and you cannot go from a node to its parent. So you can always go down. You can always go down. Can it be null? No. What are you expecting here? 1. Yes, so you're expecting 1 in here. Okay. So basically the question is here is, so let's do one of the things. 1, 3 right side, 2, 4, 5. Okay. Okay, let's first understand the problem. 1, 3, 2, 4, 5. So what is the maximum consecutive path that you can go to, right? That's basically the problem statement. And if you're here, you can either go down this side or you can go down this side. You can never come back up, which means, so okay, another question here is, what is the answer here? The answer is 3. It's 3, 4, 5, not 2, 3, 4, 5. So you cannot, okay. So that makes sense because from 2 you cannot go back to parent. Yeah. So that makes sense. So this has to be the longest path. Well, I feel one of the things we can always do is that, so as I already saw here, that if you have a single node, the expected answer is 1. That makes sense because you have a single node, right? So all the terminal nodes are having a maximum value of 1. And you can return that to the parent. The parent can either try to do a max on this side or this side. That's basically it, right? So you can simply do left is 1, right is 1, right? So because I have to consider taking this value also, or let's just say 0, 0. Very simple, 0, 0. So left is max of left and node dot left, like let's say the function call. So whatever this left node will be returning, we have to like take the maximum of it because it's 0. Like we always consider 0, right? We always consider 0. And the right is the max of whatever existing this is. But technically speaking, I can simply just say this, okay? But this node dot left can be null. node dot left can be null. So what we can do is left is 0, right is 0. If node dot left is not equal to null, then you can simply say is whatever function call is node dot left. And if node dot right is not equal to nil, right equals node dot right. And then for this particular node, what are you going to return? You're going to return 1 plus maximum of left and right. Okay, but here's the thing. We do have to check that this value is a consecutive. That is very, very important, right? We have to check if it's a consecutive one. How do we do that? We never check here, so we are just saying, okay, this is more of levels, maximum levels, right? So here we are not checking what is the like the actual consecutiveness, right? So in here, what you have to say, node dot left is not null, and node dot value plus 1 is equal to node dot right, node dot left dot value. So we do the null check before, so that this node dot left dot value doesn't crash. But the question here is a little bit different. What does it say? Consecutive sequence path. What if I take this guy, and so this here is 3 4 5. What if now I say this 4 is 2, and then the 5 is 1? Technically speaking, 3 to 1 is also, but in the other order. Do you consider that? Question. No, you do not consider that, because if you look at it, there is no consecutiveness going from parent to, well, not this, going to parent to this thing, right? So there's no consecutiveness. So you always work with increasing values and not decreasing values. So this particular condition would be correct. None of the handwriting makes sense because after school, it's been years. I think I left school in 2010. That was the last time I used well, I still have a whiteboard somewhere in my home, but this was the last time I used a chalkboard. And today is 2025. 15 years. It's more than a decade and I still can't fucking write straight. Like, I cannot write like this. I start and then it becomes like this. I'm writing on a tab right now. You guys are just wondering, I'm writing on a tab. But be it a tab, be it a chalkboard, apparently I cannot write straight. And even in my whiteboard, I cannot write straight. I don't know what's the big deal. But yeah, I hope you guys got it. If not, ask a question on the chat and I shall go over the explanation again. But that is how I feel the problem should be solved, and we are gonna see. 298. One of the things is the text is so big on my screen so that you guys can see it clearly. It's blasting off my eyes, honestly. Like, it's really huge for me. Okay, cool. I think we can copy this in here. I wonder if we could have just, created a common one. And even IntelliJ sometimes does a little bit dumb stuff. You can already see because I copied from there. It already brought in the class namespace. Okay. It's better than a lot other IDs who are even more dumber, right? So, private this in here. So if root dot left equals null and root dot right equals null, we are simply gonna return 1. And in here we can say no. Max, I'm just gonna call it max. Okay, so max of 0 is math max That's all. Okay, cool. Why like this? Because again, I can have it at the class level. I usually do not like, so yeah, this is how I want to do it this time. So now, one of the main question here is that how do I go about it? Well, it's very simple, as I mentioned. If node.left is not null, int left is 0 and right is 0, and node.value plus 1 equal to node.left. You know what? One of the thing here is that we do want to always go down. So this is kind of a little bit wrong thing. We do want to go down because what about a tree where this is 1, 3, 2, but then again 3, 4, 5. So if this particular second condition doesn't match here, this will not go down currently, right? This won't go down, but I do want to go down because this is red. So how I'm supposed to do that? Int left is like this, okay, just like this. If node dot value plus 1 is equal to node dot left dot value, then I'm gonna say left equals left. Otherwise it still go down, because why not? I still have to go down. Right, 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 and right. Okay. Int max left right 1 plus max of 0. Well, I have to bind it to something. Int max is this, return max. Now max of 0 exactly. So now here root, then you can just give max. Okay, so you can give max in here, and then am I sitting in a very weird position? I don't know. I'm not sure. Okay. So what is max? Int max is equal to 0. Turn max of 0. This is what result should be. Cool. Let's see what I did almost a year back. Okay. Okay. So I pass in the current streak also, so I don't return anything. I just manipulate this guy. Got it. But then I feel functions returning something is better, because now I can test it without just spying on things, right? Spying on if objects are being changed and all that. I can just simply test on the return value or return type. So I would say a little bit better solution than a year and a half back what I have done. What do you guys think? What do you guys think? Yeah. Cool. Let's quickly see the chat. I don't know how to delete this. Stream health is good. I don't see any frames dropping. Concurrent viewers too. Oh. Hello. Okay, cool. Shoot. Our second question. Second question is something which I haven't solved, so that's gonna be good. Return the length of the longest consecutive path in tree. A consecutive path is where values of the consecutive nodes in the path differ by 1. This can be either increasing or decreasing. That's a fucking interesting problem now, because wait, what? Why is it free now? The path can be child, parent, child order, where not necessarily parent, child order. This is an interesting problem. So you have two things to check now. One, whatever मारा उसको पकड़ने का जबरदस्ती मारा क्यों? किसी को भागते देख के उसकी फट जाती है, कुछ तो हुआ है, कुछ तो। ओके, देखो ना कैसे, अरे वो पत्ते ऐसे ऐसे करके तोड़ देते फिर खाते भी है। ओके ओके, so you have this, then you have 2, then you have 3, so here it's 2, but so you can go both ways. From any node you can go in 3 ways. You can go to either child or to parent, and you can also take your load accordingly. Now here's a problem. This can be 4, this can be 5, this can be 2, this can be 1, this can be 0, this can be -1, and here is 2. I have to consider this as the path and not this as the path, because yeah, I have to consider this as a path and not this as a path, because whatever you're doing, I feel you have to do the same thing along the way. Well, this is 4, and then this is 1, 2, 3, 4, 5. So 5 would be the answer. So this is still 1. You go up, and you say, oh, this is increasing, decreasing. Oh, cool. Sorry. That's sorry. I mean, told you I am a little I'm gonna take a quick break. I'm gonna go. My bad, sorry. I'm gonna take a quick break. I'm gonna go fill up some water, and then I'm gonna be back. Yeah. I don't want to make coffee right now because then I cannot sleep, most likely. And I'm also lazy, so that's there. Eee. Yum. Huh. Yeah, cool.
protect your soul.
Okay, we are back. We are back. And yeah, I look tired. So probably I'm gonna quickly end up the stream, but I'm gonna try to solve this problem first. Okay. Huh. So I feel here's the thing. We need to send back the information of what is the sequence we have built and the node.value. No, not quite. Node.value getting it is easy. Node.value getting it is easy. What I feel I have to get in here is two things. One on the right, one on the left. So I have to return two values. So I have to say how much I got a path in here and whether it is increasing or decreasing, and here how much I got, whether it is increasing or decreasing. That is what I have to do. And in here I have to return back the same. That is what I feel I have to do. So for every single, let me just open it up. Let me open up the chat in here. Kind of forgot. Yeah, okay. So let's do this again. 1, 2, 2, 1, 0, 3, 4, 5, 6, 6, 2, 1, 0, minus 1. So for every node, I'm going to return back two things. I'm going to return back the left, the max path, along with whether it is increasing, and the other side would be the max path, max sequence, and decreasing, increasing or decreasing. That is something that we have to return. This is going to help us determine the next steps. Right? The second thing I want to do is a max. So this is more like a max path sum problem solution, right? What we have to do is when we are returning this back, what we do is we consider the left path, whether we can go down or not, and then we return it back accordingly, and we consider the right path and we do that accordingly. That's one thing. But when we are considering the max, we consider two things. One, we consider the node itself. Well, technically speaking, node.value don't have to be considered, because anyways we'll go to a terminal node for which we are always saying that okay, it's always returning 1, so why don't you just put in the maximum sequence that you can generate, which always be. So technically speaking, this can be ignored. So the second part is depending on, so left would also say left, right would also say left, right? Depending on which side you can make a path. Like maybe for 3, for your right child, you can make a path with the left of that, but not with the right. This is what I feel you have to do. And then, can you make a path like this? And can it be a big path? Can it be a big path? Is that how you're going to solve it? I feel that's how you have to solve it. Okay. Let's see. 5, 4, 9. Well, that is not something. Okay. Let's copy this. Oh, why did I stop music? Or 1 second. No, music is playing, but I cannot hear it. So let me just reconnect. Okay. Okay. Now, this thing, right? So I feel I have to say a pair. Where you say sequence and a boolean is increasing. That's what you have to do. Private. And you always return back a pair of this. This is a node. And max. That's all. That's what you have to do. If node, so again, okay, it has to have one. So left is null. And node.right is null. Max of 0 should be max 1. Okay. And here I'm just gonna return 1. But you cannot return 1, of course. So so in here I'm gonna say new pair. This is gonna be 1. This is increasing, decreasing both. Oh. The only problem I see here is when a certain node has left and right, left is decreasing, left is right is increasing, let's say, and I return back the increasing part because it's more, but the decreasing part is small. But if I take the parent node, that would be more like more beneficial, and at some point that particular path becomes the longest. How do you do that? This guy talks about the same thing, exactly what I'm talking about. Yeah. Okay. Very poor decision. Isn't the longest path 1 to 4? The answer should be 3. Why the answer is what? Wait, what? Okay. So look at how easily this guy has done it, specifically with the fact that since you have multiple return types, it just becomes a little bit easier for you. And this is where he's returning three things, in fact, and not just one thing. So that's kind of uh, an easy thing with Python and with Go, where you can return multiple values in the same. That is kind of sus, which I don't like quite in Java, where you cannot have multiple return types. There's already a discussion from Brian. If I'm not wrong, this is where he talks about. Hmm. Exactly, you have to have a wrapper. Value types are coming in. This is like um, Project Valhalla. Anyways, but yeah, one of the things is how like the memory layout is, things like that. And yeah, you'll have something like value classes. Well, value classes are records, right? Value classes are records, but the only thing is that it's going to be in line on the stack itself and not on the sync, things like that. But yeah, it's pretty cool way of working with structs. It's basically structs, but not classes anymore. Right? That's all. That's all. Hmm. Hmm. Okay. Yeah. Okay. So it's not sure how we're gonna go about with this. I thought this is the answer, but this is clearly not the answer. I feel like we have to do something what he has done. So Yeah. I'm gonna park this guy for later on because my mind is already not kind of working. Sorry. My mind is already not kind of working. So yeah. Let's try to do this. Maximum sub average tree, which is also something that we haven't done before. Given the root of a binary tree, return the maximum average of a subtree of that tree. Answer within 10 to the minus 5 of the actual answer will be accepted. A subtree of a tree, okay. The subtree of a tree is any node of that tree plus all its descendants. The average value divided by the number of nodes. Okay. Okay. This seems like a very simple problem because you have 5, you have 6, and I think you have 7. That is probably what you have 1. I mean, it really doesn't matter. So what is the maximum average here? The maximum average here is 1 by 1. So it is always gonna be node dot value. Where are not just copying the buffers from? Node dot value divided by 1. It's always gonna be this at the terminal leaves. Right, that's what it is. It has to. The second thing that we have to talk about here is that how do we even like consider these things, right? So you have to pass down the sum and the node count and the node count. That is all. So at every node you have to first get the left one. So let's say you have sum 1 and count 1 for left, call the function sum 2 count 2 for the right. Okay, and then in here what you have to do is sum 1 plus sum 2 plus node dot value divided by c1 plus c2 plus 1. That is what we have to do. That is what we have to do. Okay, so let's try to do that. 1 1 2 0. Record is not a value class. It's not a struct. It's a data class. Okay, it's a data class. Anyways, pair. So int sum, int count. So here you have to return pair, since node, and double max. That's all. Okay. So now what you simply have to do here is that if, again, one more thing. Okay. If node dot left is null and node dot right is null, max of 0 is max node value, and return new pair node value 1. Int sum should be equal to node dot value, int count is equal to 1. If node dot left is not equal to null, maximum average node left max pair this thing. Okay, pair dot sum count. So in here it has to be right, so it has to be right and this thing. So return new pair someone count. But before that, kind of have to do that again. But in here, you say sum. That's all. All the function in here, you don't need to return value. Here you pass root. Here you pass max, and that's basically it. And here it has to be 0 and return max of 0. And it should be that simple. I don't know why I never solved it before. Did I? I didn't solve it before. Okay. I feel that should be it. And that didn't work. Okay. Okay. Why did it not work? Mm-hmm. What did I do wrong? Oh. Good. So we solved another one. Awesome. Apparently I've solved this before, so let's try to do that. Given the root, return the number of uni-value subtrees. A uni-value subtree means all the nodes of the subtrees have the same value. Okay. Sorry. All the nodes okay. I think I've got a good idea here. See, it would all depend on the terminal nodes, because if the terminal nodes are certain values, then it cannot work. Because if you break at a certain terminal node, it means that it basically means that you cannot go back again. Like the above ranges, you can never generate anything, right? So it always has to be dependent on the terminal nodes, because the terminal nodes is where you start looking at the subtrees. So if the value is 5 here, the value is 6 here, so 5 and 6 are okay, but the very above one is going to be a break, because both the left and right are like the same, right? So one of the things we have to see here is it's 0. So if it's 0, we have to take care, like if it's null, basically we take care of it separately. If not, then we have to take care of it. So here is what we're going to do. Okay. Private int count node. So I'm not sure if we can, like if we have to do something else in here, but let's see. If node.left is equal to null and node.right is equal to null, turn 1. So you have one count at least. Right, you at least have a single counter. Okay. I'm wondering if I should return the count or I should return. I think I should return the count because that kind of becomes a little bit easier because I can easily look at the values of my children, is what I feel. Okay. The second thing in here is that, so, well, okay, I can actually do the diagram for this. So in here, what I'm looking for is, so what I'm looking for here is that Boolean flag is false, is true. Okay. So now I'm gonna say if node.left is not equal to null, sorry, count internal node.left, and okay, if count is still 0, well, no. If node.left.val not equal to node.val, or let's do it in this way. Flag is false. So you do for right. You do it for right. You get the count. Sorry. Right. If flag, you can simply say count plus plus. I feel there's a problem here. What is the problem? Because if it was 5-5 and then above we broke the pattern, right? If it was 5-5 and we broke the pattern, even after we go up, we are just looking at the child. We are not looking at the children of children, right? So that kind of breaks the pattern and says, oh, I don't know, like it would be true. So that's the problem. So this is where I was saying we probably cannot return integer. We have to return a boolean. I feel we have to return a boolean and not an integer. All right, I feel that is what the case is. Okay. So in that particular case, what I'm gonna do here is, I think it needs to return boolean. And yeah, in here I'm gonna do it this way. Private int count. Count plus plus and return true always. So if node.left not equal to null, count internal node.left. If it's false, you can simply return false. So in here it's right, in here it's right. If you have survived these two cards, and we can kind of, you know, because if node.left is null, you never go in here. So we can merge. So this expression never gets evaluated, which means it never goes in here. So if it's empty, you should be good. Sorry. which also means I can inline this. Yeah, so return false. In here, if I have reached at this particular point, I know for a fact, yeah, इधर जाना है. But most importantly, this node is also going to be counted as part of this thing, right? So that's one thing you can always do. And so this is going to be the root. If root is null, you can return 0, then this thing, and then we can return count. So we can do this, you know. I think that's a good idea. Let's see. I think this is gonna work. If the mental calculation is correct, this is gonna work. But let's see. Awesome, it didn't work. You're expecting 4, but we got 5. So we got 6. Cool. I know. I know why. Because here now you have to check node dot yes. So if this is this, then you return this. That's one thing. If I'm not wrong, that is one thing. Okay, you're still at the wrong, so that's fine. Question is why? Because every time you kind of reach this thing, right? Every time you reach the terminal node, so you always say, okay, you can increment the count. And then if, you know what? Wait. I feel the conditions are a little wrong, right? Because if node dot left is not null, so that is when you would evaluate this thing, which if it returns false, wait, why are you doing the other way around? That's wrong, right? Because if it is there, yeah, because I already did De Morgan's law where I kind of put together two things and I have to then negate it out. Makes sense. Question is, can I put this also in there? If I'm not wrong, that is how you can do that. Let's see if I'm not wrong. Okay. Yes. Well, I mean, maybe it's a little complicated to read. I don't know. Once I understand it, kind of becomes mentally more easy to read, but maybe at the first time it's not. So maybe it's not a good code. And we have a wrong answer. Awesome. So use this test case and let's see what exactly you're talking about. So you have 1, 2, 3, 4. 4 should be the answer, but you have given 3. What did I do wrong in here now? Node dot left is not null. That is when you try to go down the tree on the left side and you're also expecting a true value from it. If you got a true value, What if I inline this? Like, I feel my conditions are a little... Node dot value is not equal to node dot write dot value. If I do this, yeah, it's still an issue. But why? But if you survive the left node branch and the right node branch, even if it was null, so left is null, so you don't go in here. But right is not null, so you survived it some. You're still incrementing count plus plus. So why would it not increment? Why would it not increment? Where's the test case? So this is 5 and all that, blah, 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 and all that. So 1, 1, 1 is 3. And this one should be 4. But it never incremented. Because when you're there, you're saying no dot left is not null. Yes, that's correct. So then you go down to the left. And it's a terminal node, so you return back true. And you increment the count, that's fine. So when you come back in this particular call trace back again, this is true. So I shouldn't break the streak. I should go inside it and I should say, oh, it's not equal to the left one. No, that is not correct. That is correct because the value is correct. The value is same. So we don't return anything and we come here and we do the same thing for right node. We do the same because I have a feeling that this is where I'm getting missed, right? It cannot miss in all these conditions because this is the base condition of a very straightforward thing. But did I do that right? Node dot left, node dot right equal. Yeah, that's correct. So in here now, what I have to do is node dot right is not equal to null, and then count the same node right. Kind of do the same thing. And if you pass both the cases, it means that either it was a left node or your value is the same. Either it was a null node or your value is same. If that is the case and you return me back true and you passed all the branch conditions, you're gonna say that okay, this one also is part of another subtree. So this is another subtree which is good. So I can increment the count by 1. This is where I do it. So 1, 2, 3, and then these 3 things together is another. That is what it is. But the good question here is, why on earth? Why on earth you're saying that you're You know what? Awesome. None of them worked. A hero. And what am I doing wrong? This first of all is stupid. This is correct. This is absolutely correct. There's no break in logic in here.
Kids screaming in their cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who
It says hello.
my cries and
Says hello.
watch me weep. I love everything. Fire spread
It says hello.
my words so bright.
So,
Hard to breathe, but that's all.
does it say hello 3 times in here? It only says twice. That's the problem. Wow.
Take my eyes open to force reality. Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in their cradles, profanities. Some days I feel skinnier than all the other days. Sometimes I can't tell if my body belongs to me. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. I wanna taste your content, hold your breath and feel the tension. Devils hide behind redemption. Honesty is a one-way gate to hell. I wanna taste consumption, breathe fast,
It never went in here. But that's correct.
sing aloud
That's correct.
till the wick burns out. Just wanna be carefree lately, yeah. Just kicking up daisies. Got one too many quarters in my pockets. Counting like the four-leaf clovers in my locket. Untied laces, yeah. Just tripping on daydreams. Got dirty little lullabies playing on repeat. Might as well just ride around the nursery and count sheep.
Just like the street lights lit this town, like a fire in a blaze, gotta burn it down. Can't be afraid to leave this out. We got this far, don't know how. I see danger in your eyes. They know we'll
Let's do very simple. Okay. So if node is not null,
like the sunrise. Know that we gonna let it out tonight.
you do that. You do that. And if this comes out to be false, you'll return false. Simply. And if this is true, you come down here. If node.value is equal to node.value node left.value is not, you return false.
Just like a spark that's breaking out. Can't make a stop.
Wait, what is going on?
We know that there's no room for doubt. No, we can't turn
Yeah.
back now. I see
And then in here, node dot left can be replaced with node dot right. If I do it in this way, very simple, it still gets fucked up. Okay. I think I need a really good sleep to even start thinking about what the heck I'm doing. Okay. So, what are the problems we want to solve in here? What are the problems we want to solve in here, huh? Ternary expression parser. Okay, let's see if we can solve this. Given a string of expression representing arbitrary nested ternary expressions. Oh, this is going to be the last one because it's already 12 o'clock. Okay. Given a string expression representing arbitrary nested ternary expressions, evaluate the following expression. Huh? Wow. But it's already 12 o'clock and I haven't had dinner. Okay, wow. I think I'm going to end the stream today. And not a really productive stream, but that's fine. Again, tomorrow we'll be grinding. Tomorrow is a Friday, so I'll do a little bit late night and I'll try to actually come early. But let's see. Yeah, thank you so much everybody for joining. Thank you so much everybody who joined. Thank you for the support who liked the stream. Thank you for the support who subbed today. There's one subscriber I got, so thank you so much for subscribing. I think I already know who subscribed because anyways. So thank you so much, and yeah, have a good day, have a good night from wherever you're watching, and see you next time. So thank you, bye bye.